Okay, so today I'll be explaining this boosting ensemble technique, which is called Adaboost, also known as adaptive boost. So uh, okay, let me give you a rough idea about Adaboost first. So in Adaboost, when a data set is given to Adaboost, so it tries to boost its own errors to the next model. It is actually combination of lots of models, and the first model tries to boost its own errors and send to the next model. Okay, it will try to add some weightage to its own errors and tries to give to the next model, so that gradually this error, the training error, will keep on decreasing and end up gradually creating a low bias model. Okay, so let's go further and try to know the in depth. Okay, so suppose this is a data set. This is a toy data set that I have taken, having two independent columns, x1 and x2, and y is the uh, dependent feature. Okay, and this is the sample weight. How the sample weight is calculated? Actually, here the number of rows is 5. So every row will be given equal weightage. So 1 by n, 1 by number of rows is equal to 0.2. Okay, so now the very first step is over. So next we'll move to, okay. Now, next, for now, it will start creating weak learners. Okay, weak learners or base model, what not base learner but weak learners. Okay, so first of all, it will based on this x1 and x2, it will try to create decision stumps. What are this is example of a decision stump where the actually it is a decision tree with a depth of 1. Okay, so obviously, if decision tree is having depth 1, so it will be a very high biased model. So now it is a very high biased and low variance model. It will give a lot of training error. Okay, so this first decision stump is giving this prediction, this y pred. Okay, for every row, it will try to give a prediction. So, it will, of course, it will do some errors, and you can see here, as you can see here, for row number 2 and row number 3, it is doing misclassification. Okay, so we have to when the prediction is done for this decision stump, we have to calculate the error for this model or this decision stump. So for calculating the error, here is the formula: sample weight into the number of misclassifications. So here, two number of misclassifications have been done, and the sample weightage is 0.2. So the error is 0.4. Then the next step is we have to calculate a significance of this model, the whole weightage that we need to give to this model, or I can say the say of this model, we have to calculate. So this is the formula: significance is equal to half log into 1 minus total error divided by total error. Okay, so now next we have to update yes, we have to update this weightage of every row. Okay, so there are it is now a combination of correctly classified and misclassified row. So we have to increase the weightage of the misclassified rows and decrease the weights of the classified rows. As I have said previously, that it will try to boost its errors. That's why it is increasing the weights of misclassified rows. So this is the formula for misclassified rows: current weight into e to the power alpha 1 means the uh, error. Okay, so this will be the new weight for the misclassified rows, and this will be the weightage for correctly classified rows. You can see here there is a minus sign. So what this will do is it will decrease the weightage for the correctly classified rows. Okay, uh, then uh, So here the table is updated. Okay, so new weightage have been assigned to this whole table. Okay, so new weightage have been assigned here. And another thing, this weightage are now normalized. Previously, the when we were calculating this number 0.24 and 0.16, when we are adding all the rows, all the weightage, it should be 1, but it was not adding up to be 1. So we have to normalize the whole all the numbers. So this is a normalized column also. So new weight is this. So uh, then then a very important step here is we have to do upsampling here. Okay, so what is this upsampling? So actually, with the help of this weightage, I am creating, you can say, bins or windows. Okay, from 0 to 0.166, and likewise, I am creating a range for every row. Okay, and why? Because see, the second row and third row are having higher weightage than the other columns. So the ranges or the bins of these two rows will also be higher than other correctly classified rows. So misclassified rows ranges will be a little bit higher or wider. Okay, then what I'll do is I'll try to pick up or randomly pick up some numbers from between 0 and 1. Okay, and when I try to see those and try to see the numbers are from which bins or which ranges. So obviously, since this row number 2 and row number 3 ranges are wider or higher, so most of the numbers will fall inside this range only for the misclassified rows. Okay, then this data set, this old data set, will not be sent forward to the next model. Okay, which data set will be taken? Suppose from five randomly picked numbers, two numbers are falling inside the this 0.166 to 0.416, and two numbers are falling inside the this range of this third column. So this second row, second row will be taken two times, third row will be taken two times, total four rows. And suppose another number fell between 0 to 0.166, so this first row will be taken, total number of five rows. Those five rows and that new data set will be taken and sent forward with new weightage, with the recently this calculated weightage. Weightage will be that zero point 0.2 will and sent forward to the next model. Similarly, this process will continue until until the it creates overall, it creates a low training error model, a low biased and low variance model. Okay, then at last we will calculate this p. P is alpha 1, means the weightage of the first model and the prediction of the first model. And similarly, it will add up all the values and give you the final prediction. Okay, the basic concept here is it is trying to boost its own errors. Okay, suppose there are 10 models have been created. Every model will boost up its own errors and send forward to the next model until and unless all the training error have been decreased and creates a optimized model. Okay.